Hello, this video is to show you how to complete the square, also known as graphing form. Before I start, I want to make sure you understand what makes a perfect square trinomial. So basically a perfect square trinomial is when you multiply a binomial times itself. So this x plus 5 squared is really like saying x plus 5 times x plus 5. So if I multiply this out, if I do it, let's say I use it as a distributive property, I would do x times x plus 5 and then 5 times x plus 5. So when I do that, I get x squared plus 5x for the top, and on the bottom I get 5x plus 25. If I put my like terms together, I get x squared plus 10x plus 25. Now that's just showing you the, again, distributive property for doing this. But again, there's a pattern to this. Basically what you do is you square the first number in the parentheses. That would be x times x is x squared. You multiply the stuff in the middle, or in the parentheses. So negative 4 times x is negative 4x, and then I double it, which would be negative 8x. And then negative 4 squared is 16. And if I go back to this previous one, you can see that I have 5x and 5x. That's why when you multiply these together and double it, because it's the same binomial times itself, you're going to have that happen all the time. So again, if I square this first term, 2x times 2x is 4x squared. If I multiply the inside numbers in parentheses, 3 times 2x is 6x, and double it, I'd be at 12x, and 3 times 3 is 9. And again, we're just showing you some different combinations of plus and minus signs, but this pattern works for every one of them. So 4x times 4x is 16x squared. Negative 7 times 4 is negative 28. Doubled is negative 56. And negative 7 times negative 7 is 49. Now these are perfect square trinomials because I'm actually multiplying the same binomial times itself. Okay, so sometimes when you complete the square, you might have a piece that's missing and you might have to add something to it. And sometimes when you complete the square, you have a perfect square, then you have a couple pieces or a couple values beyond it. So that's why this graphing form, which comes in as y equals a times x minus h squared plus k. So again, this is where we're completing the square, making a perfect square trinomial as far as this look to it. And then this k is where, again, we might have a little bit too much or not enough, and we have to add or subtract to complete the square. Okay, so this is what I consider level 1 for this next part, using that same pattern. So if I gave an equation like x squared plus 8x minus 10, well, what I do is I just put a bracket around the first two terms. I ignore the c value in the quadratic for a minute. So if I want to go ahead and make this into a perfect square trinomial for what's inside this bracket from that pattern we just talked about, the only way to get x squared would be x times x. Now remember, when we multiply these together and double it, I have to get 8x. That means this has to be a 4. If I go ahead and do that shortcut, x times x is x squared. 4 times x is 4x, doubled is 8x. And then 4 times 4 is 16. So right now you can see I clearly have made these two pieces for my original equation. But right now I'm at positive 16. To go from positive 16 to negative 10, I would have to subtract 26. So now this is my graphing form for the standard equation that I started with. The power of this is I can immediately find my vertex. The vertex is what makes the inside of this parentheses equal to 0, also known as the opposite of h. So to make this equal to 0 would be negative 4. And that's always my k value. So in this case, it would be negative 26. So again, I've finished completing the square, putting it in graphing form, and I found the vertex of my parabola. To find the roots, what you would do is, if this is y equals, is a traditional equation, if I make the y equal to 0, I'm just finding the x-intercepts or the roots. So if I go ahead and do that, I have 0 equals x plus 4 squared minus 26. So if I'm going to go ahead and backtrack this, I'm going to add 26 to both sides first to move that over. Now I have 26 equals x plus 4 squared. Now to get rid of a square, you have to square root it. And what's important when you're backtracking and square rooting, this answer becomes plus and minus. And again, why that would make sense is if I had a question like this as a side note, x squared equals 100. When you plug in a variable value, it's assumed it's in parentheses. So I could put in negative 10 squared, which would be 100. I could put in positive 10 squared, which is 100. And so when I'm doing this, I get the plus and minus 26 in this case. So then, I should say radical 26. So then I'm going to subtract 4 from both sides. So then my exact answer would be negative 4 plus or minus radical 26 would be my two roots or my x-intercepts. Now it depends on what you need to do. Most people would round that to the nearest hundredth and give an approximate answer. But again, easily you could find the roots, the vertex, from the graphing form. I'm going to do one other example with this, which I can still consider level 1. And level 1 is where it just has an x squared in it, but it doesn't always end up being a whole number. So here's an example where I have something like this. So again, I want to fill in and complete my perfect square trinomial. So obviously x times x is x squared. When I multiply these together and double it, I want to get negative 7. This has to be a negative 3.5. So again, when I multiply this out, I'll have x squared. This times this is negative 3.5 doubled is negative 7x. And then negative 3.5 times negative 3.5 is positive 12.25. So to go from 12.25 to 11, I would have to subtract 1.25. So this would be my answer for the graphing form, completing the square. And again, my vertex, what makes this equal to 0, would be positive 3.5, negative 1.25. That's my vertex. And again, if I wanted to find my roots, I would make this equation equal to 0 to find my x-intercepts. Then I would simply backtrack. So again, I would add 1.25 to both sides. So I have 1.25 equals x minus 3.5 squared. Again, the opposite of squaring is to square root. And as soon as I do that, this becomes plus and minus. And then the last step would be to go ahead and add 3.5 and add 3.5. So you have 3.5 plus or minus the square root of 1.25 would be your x-intercepts or your roots. And again, this is the exact answer. If you want an approximate answer, you can square root this on your calculator, round to the nearest hundredth, and then add that to 3.5, and then subtract that value from 3.5 to get your x-intercepts.